Maths educational video. Examples of convergence sequences. In this video, we will look at a special type of sequence. A sequence of the form P over Q, where P and Q are sums of non-negative powers of n. Here are some examples of such functions. Obviously, all polynomials in n are made up of powers of n, and the powers are either 0 or any positive integer. But the powers can be any positive real number. So in the second example, we have, for example, square root of n, which is n power half, a positive real number. And our job is to find the limit of the ratio of two such functions. I'll illustrate the method using two examples. But first, a quick observation. This type of limit is always of the form infinity over infinity. For obvious reasons, both the numerator and the denominator will diverge to infinity when n becomes very large. And the method to find such limit is to divide both the numerator and the denominator by the highest power of n that you can find in this function. So let's look at the first example. Obviously, the first thing to do is to look for the highest power. Numerator, the highest power is n power 5, that's quite obvious. As for the denominator, we can find that the highest power is also n power 5. And that's because from the first term, you get highest power n squared. The second term, highest power is n cubed. So together, highest power is n power 5. So the conclusion is, the highest power you can find in this function is n power 5. So we are going to divide both the numerator and denominator by n power 5. And let's do it term by term. No problem for the numerator. We divide each and every term by n power 5 to arrive at this expression. As for the denominator, we might want to apply some trick. Instead of dividing the whole expression by n power 5, what we can do is we divide the first term by n power 2 because we have a square here, and we divide the second term by n power 3. And doing so will enable us to simplify the expression in this manner. For example, the first term can be written as 3 minus 1 over n to the power of 2. And now we can let n go to infinity. What we notice is that we no longer get infinity over infinity. What we get is either a number or 0. Those terms involving reciprocals or powers of n will all go to 0. So the outcome is, for example, numerator will become 6. Denominator will become 3 squared times 1. So that gives us an answer of 2/3. Let's look at the second example. Again, we identify the highest power of n. In the numerator, the first term will have a power of n power 2.5 because n times square root of n cubed is n power 2.5, 2.5. Second term, n power 3. So between these two, obviously n power 3 is the higher power. So we will divide both the numerator and denominator by n cubed. And again, we do it term by term. Let me elaborate on this part. What you can do is, first of all, you cancel n with n cubed. That will give you n squared. And next, you will bring n squared into the square root. And once you bring n squared into the square root, you should have n to the power of 4. And this will take us to the following expression. And now it's time to take limit. When n goes to infinity, we look for those terms that will become 0. Let me circle them. All these terms will go to 0. Same for 1 over n in the denominator. So as you can see, the outcome is simply 0 divided by 2 cubed. And so the answer is 0.